All right, this is Wayne, and we're going to give this a little bit of a shot at trying to explain something that is pretty difficult to wrap your mind around for a lot of people. And I'm going to try and do it without any of my props that I normally do when I teach this subject. And that is the concept of entropy. Entropy really is nothing more than randomness or disorder within a system. And the larger the system is, the larger the entropy can be. And this takes a lot of different forms. And there's many of them that you may be familiar with, some of you may not be. The second law of thermodynamics, very, very simple. And to put it the way the entropy works in the simplest form of this, would be if I took a hot ball of metal and a cold ball of metal and connected them together with another bar of metal. The heat energy would travel from that hot sphere along the bar to the cooler sphere until it equalized and reached that equilibrium. As that energy flows, it's a random. This is that entropy, and it's this disorder to it. Some of the other examples that I've used is a cup of crushed ice and a cup of water. Which one has more entropy? Which one has more randomness or more disorder to it? Most frequently, we hear that it is the crushed ice. Okay, you can see more of it where water is just water. But you have to bring this down to the molecular level, and that's what I'm assuming we're really looking at getting to here with the biochemistry end of this, is looking at the energy that is at that molecular level. With ice, even though it's broken into these little pieces, those hydrogen bonds, they don't have any energy to them. This is why it's in that crystalline structure. This is why it's formed a solid. So those bonds are very rigid. They're not moving anywhere. Okay, they've set themselves out and they formed that lattice and said, I'm here, you're here, and this is where we're going to stay. But as energy is added to that, as energy gets added to it, as heat gets added to it, the ice begins to melt. As those hydrogen bonds take on this energy, what do? They begin moving. And as we have these constant movement, we have all these different states of energy that water is in as it shifts from the solid to the liquid form. And then it continues even further as it moves from the liquid form into that gas form. Another way that I've used in the past is to think of it as probability. If I have 4 coins and I randomly just flip these 4 coins at one time, is it possible to have all 4 coins come up heads or all 4 coins come up tails? Yes, it is possible. Is it likely? No. Okay, but it is going to eventually happen if I do this enough times. But if I make it a much larger system, and instead of using 4 coins, I now use 100 coins. Now, what are the odds that I'm going to have 100 coins come up heads? Okay, I've got better odds of it coming up 99 heads and 1 tail, okay, than I do all 100 heads. And there's different statistics that go into this. There's different probability, and from even the thermodynamic ends of it, there's just so many different equations that are involved in it, and some of them come into play with Gibbs free energy. And so there's a lot of different probability, a lot of different statistics that are involved in this. It is an extremely difficult concept to grasp, and you really need to focus in particularly on the individual area that you need for that specific subject, or for that specific area that you are looking at. Well, I hope this explained a little bit. Probably not, probably confused many people more than you were before you heard this, and that's okay too, but hopefully it set the groundwork to help you better understand, that this entropy is really just randomness. It's disorder. It's almost like chaos, and it does change. And that the bigger the system, the more bonds, the more molecules, the bigger this entropy is. And when we have more entropy in something, especially when we look back at the thermodynamics and second law of thermodynamics, this energy, this entropy, is basically energy that's not available to do work. So as we have larger entropy, we have less energy available to form bonds. In the ice example and the different states of water, less energy, okay, would be there to form those hydrogen bonds and to make them be maintained into that solid form. So again, I hope this helped a little bit, and good night.